Welcome in this video. I'm Eugene Rimenyurifite, the student in Bengono Toure Genevieve University Institute. I'm a student in year 4 civil engineering, and this is engineering design workshop and technology. We are going to discuss about the description of sheet metal and fitting. We will also see various kinds of tools, equipment that are used in sheet metal and fitting. Last time we saw about the tools that we are using in carpentry, in foundry and so on, but today we are coming in sheet metal. Sheet metal, if we are saying about sheet metal, we are referring to the metal forming or metal which is formed into the flat pieces or the piece of small thickness. Actually, we say that metal, it is a sheet metal, or when it is having the thickness which is varying from 1 to 3 millimeters. So from there, we'll say that it is a sheet metal. Otherwise, when it is going above, it will be called a plate. Lightweight. We have also the characteristics, or the sheet metal will have some characteristics which will be the first point which will be based on when you are selecting materials. Here it says that the product are light and strong, means when we are making a product in sheet metal, this product will not be too heavy. Okay, it is having many characteristics, but it means material loss is low when we are producing something in sheet metal. The wastage will be very low, means it is economical. When we are using mass production, or when we are using many people to perform something, so it will be possible, because one will come to do measuring, the second will come to do marking, the third one may come to do cutting, and so on. So everyone may come to perform his or her task. And then we need also to understand about the mechanical and sheet metal machining. When we are saying about mechanical and sheet metal machining, we have to deal about the types, or we need to know about the groups of sheet metal. If we say a sheet metal it is a thin, or when we are having thin plates, we will say that it will be called general sheet metal. But if we say that we are using the flat plate, so this will be called boiler making. Let's say about the procedures for general sheet metal. When we are saying the procedures for general sheet metal, this will start from the preparing of materials, and it will end by the inspection of the defects. So what are we going to do here? What we are going to do, we are going to perform something real. Means here we are going to build something, or we are going to do production. When we are going to produce something from sheet metal, we will start by assigning materials. On the part of assigning materials, it is when we will be selecting the materials to use. We have number two, it is drawing up development figure. The development figure, it is like a plan. It is like when the constructors are doing the plan of a house. It is when you are drawing what you need to produce or what you need to perform. So here also on the drawing up development figure, so here we need to know what we want. So from there we will do sketch or we will do drawing on Bristol paper, and then after we will move to step number 3. It is patching out plate. So to patch out plate, it is when we bring our sheet metal, we take the drawing that we have made, we lay it on the top of a sheet metal, and then by using the center punch and a hammer, we will mark the point. We mark the point from the drawing to be punched on a sheet metal. And then after marking or after putting or marking all the point, we will move to step number 4, which is cutting off. But before cutting off, we will need to draw the lines which connect this point that we have put on a sheet metal. So we will use the rulers or squares, and we will use a scriber to take this or to scratch on a sheet metal to put these lines on the sheet metal. And then cutting action will be or will start, will go ahead. Then after cutting, what will be next? It is about bending. So we will bend about how or according to how we need our production to be. After bending, we will make joint or we will join. So this joining, it may be done by welding or it may be done by seaming. So it will depend on the product or the final product you wish. And then after joining, we will come on inspection. For the inspection, we will be checking the dimensions. If the let's say for example it is a cylinder. If it is a cylinder, we may check the height. We may check the diameters. We may check the joint. So for the joint, we may check the width of a joint. We may check the thickness of a joint, and we may inspect if there is no leakage in our joint. And from there, we are having a product. Let us talk a little bit on materials that we use in sheet metal and fitting. In sheet metal and fitting, we use materials which may be ferrous materials or non-ferrous sheeting materials. In ferrous materials, there are these materials which contain iron. So every time when we say ferrous materials, we are referring to materials which made up with iron. So it may be iron, pure iron, or it may be alloy mixed with iron. So here, these materials of ferrous materials, they are materials which is widely used because they are very malleable and ductile. So to be malleable or malleability, it is when you can hammer a material and it may be flat. So from there you say that it is having malleability. So this is a known property on ferrous material. It is also ductile. So the ductility is when you can pull a material and it can be drawn into a wire. So it cannot break easily, but it is reducing the size before it breaks. So this is also a good property in machining. So it is reason why the ferrous material are widely used. But it is not only that, because the ferrous material are very strong, they are very hard, they are resistant to abrasion and so on, but they are also corrosion resistant. If we say they are corrosion resistant, it means they resist to corrosion, but they do not resist much or higher than non-ferrous material on corrosion. We cannot forget that these materials are long lasting. It means they are durable. They can be used for so long time. So it is the reason why these ones are used to make the home appliances. Special purposes. For example, when you make aircraft, when we need to make something which we do not need to be heavy, we have tools that we use to make all this we have said. So we need to perform anything on sheet metal, you need to use a tool, you need to use equipment. So what you need to do, it is to select well a tool or to select well equipment which will help you. When you are selecting tool or equipment, what you need, it is to select a tool which will be efficient to what you need to do, or which will help you to save the time, and which will bring zero defect on the product. Let us say about the hand tools. The hand tools that are used in sheet metal and fitting, they are grouped in four groups. Group number one is measuring tools, two marking tools, three holding tools, four hammering tools. When we are starting with measuring tools, we are having rulers or steel ruler, we have square, we have calipers, level, vernier caliper, micrometer, dial gauge, height gauge, thickness gauge, wire gauge, and drill gauge. So here we have illustrated few of them. We have illustrated a steel ruler. So as you are seeing here, we have steel ruler. It may be long to have 1 meter, or it may be short to have 30 centimeters. So it is graduated. So it is having the measurement that you can use when you are measuring. So you will see some of these rulers may be in imperial or in a metric system, or some of them are in both. They are graduated in a imperial system and in a metric system. We are having also tri-square or a square, simply square. So this square, it is having stock and blade. Here on the blade also it is graduated so that you can use it to measure some small distances. We are having a vernier caliper. A vernier caliper, it is an instrument also which is used to take some different measurements, like external measurement of cylindrical elements. Here we are using these jaws. These jaws are used to take some external diameters. Here, these upper jaws are used to take internal measurement or internal diameters of some cylindrical elements. And we are having here the stem. This stem, it is used to take the depths or to measure the depths of cylinders or the holes. Then after, we are having what we call vernier scale. Vernier scale, it is this part. Okay, this part is called vernier scale. And here we are having main scale. This main scale, it is graduated like a ruler. And then when you take a measurement which may be external, internal, or depths, what you will do, it is to look here on the vernier scale, and you will check where is 0. Sorry. And then you will see on the main scale the number which is meeting with 0 of the vernier, and that will be recorded as it may be in centimeters or in millimeters. And then and then you may need to read the small part of the millimeters. So there's small parts of the millimeters, you will read them here on the vernier scale. We will look for a number which will coincide with another number, a number of the vernier which will coincide with another number of the scale, and then you will count on the vernier. You will count these small pieces or these micrometers. So you will read, for example, if the number of the scale which mates with the another number of the main scale, if here the number is 7, so you will have the millimeters point that 7, and according to the scale of the vernier. We are having marking tools. For marking tools, there are these tools which are used to draw the lines or to mark where we will cut, to mark the centers and so on. So these marking tools, from them we are having like a divider. This is a divider which is somehow similar but not exact with the compass. The difference is that the compass, it is having where to put a pencil, but here on the compass it is not, on the divider it is not there. We are having this divider. It is used to report some measurement, take measurement and report it somewhere else. We are having center punch which will be needed to put the centers, to mark the centers. We are having the scriber which will be used to scratch on a sheet metal or to mark the lines on the sheet metal. We are having cutting tools. These cutting tools, we are having snips or chisels, we are having punches, we are having chisels, we are having files, and a gas cutter torch. Here we have illustrated the snips or scissors. These ones, they will be used to cut the lines that we have marked with the scribers. And we are having chisels also. They are used in cutting, and the file which is used to remove some small particles of metal. We are having molding tools or hammering tools or molding tools. So here it comprises the hammers and the wrenches. So here we are having the ball pen hammer. Ball pen hammer, it is a hammer which will be used when we are finishing our product. It is having a flat part of a flat head and a concave one. We may use one of these ends according to the product we need. Here we are having riveting hammer which is used to fix the rivet. Here we have a plier. This plier, it is called groove plier. It is used when we need to fix or to remove, or when we need to hold something. We have also wrench. This is a wrench of a type of chain. It is called a chain wrench. This one also, it is used in fixing. There is holding tools. In holding tools, we have illustrated the vices, bench vices, and the clamps. This is a G clamp, and here we are having three shapes of bench vice. This is universal bench vice, and here we are having a bench vice that is used to hold something cylindrical or which is having which is having cylindrical shape like a ball. And we have also another vise, bench vise, which is sometimes fixed on a machine like drilling machine, where it is used to fix the piece on what we are going to, on which we are going to operate. Let's move on equipment that are used in sheet metal and fitting. Equipment, we have used a few equipment, but there are many equipment that are used in this shop. Here we are starting by shearing. This shearing, they are machines or equipment that are used to cut the sheet metal. This is a shearing machine or power equipped shearing machine. This one, it is used to cut. So here the sheet, it is put here on the table, it is adjusted according to the marking we have marked, and then we command a machine to cut. A blade will come upward, downward, and then it will cut our sheet. If we are having the small width sheet, we can use lever sheets. We can use lever shearing machine. So this one, it is manually powered. So the sheet will be put here on the jaws, and then by turning the lever downward, it will cut the sheet. We are having bending machines. These bending machines, as the name says, it is used in bending, but bending or folding. But we are having two kinds. Kind one, it is box and pan brake. This one, it is used when we need to fold or to bend the four parts or the four sides of a box. So when we need to fold one side straight, we will use press brake. We are having forming machine. So this forming machine or rolling machine, it is a machine that will be used when we need to form like undulation on our sheet metal. So we use this machine. We cannot leave this part of machines without saying about the machines that we can use after bending. When we finish bending, we may decide whether to use seaming or welding. When we have used welding, we need to use some machines, of course, to weld. So we may use arc welding, where we may use electricity. So here it may be AC arc welding, or we may use the DC arc welding. All of them, they are electricity, both. But you may even use gas welding, where we use acetylene gas and the oxygen gas. Each one is kept in its cylinder, and then we may weld as we wish. Let us talk about engineering process of forming or engineering process of sheet metal working. Here I have choose that you may say about the seaming. Seaming, it is how you can do a joint, or how you can do a joint after you have finished your product. So this product, so it may be, for example, it may be the pipe, it may be the top of roof covering, it may be the chassis of automobile, and so on. So here we are having some different kinds of seaming. So it is called seaming. Let's say a little bit about fitting. Fitting, uh, they are these connectors that are used in pipe work. When we are conveying the fluid into a pipe, this fluid may pass in a different direction. in a different dimension, so of the diameter. So these connectors that we will use, they are called fitting. So the fitting cannot be separated with sheet metal, because we use sheet metal to produce fittings. Here we are having some different kinds of fitting, like elbows. There's elbows on different angles. This is T. This is also T, reducing T, because the branch is smaller than the main part, so it will be called reducing T. We are having this is also a T. We are having the adapters. We are having reducers, and so on. These are the types of fitting that can be made in sheet metal. Doing on a cylinder. So it means here we are having a circle. So what we are having on the step number 2, it is a half of a circle. Okay, or the top of a cylinder. It is a circle always. And then, because we have cut, we are looking on the half of our circle. And then we need it here. We have divided it into 6, but you can even increase this number, because it will depend on the size of the project you are doing. But as you are reducing this angle, it is called space angle, or angle of space. As you are reducing this space angle, you are increasing the accuracy. And then what you will do, you will put the point 2, because 1 it is here, and 7 it is here, direct on the touch point. And then you will write, you will put the angles by using the by using the divider. You will put 2 3 4 2 3 2 3 5 and 6, because 4 it is also on the axis. And then the next step, you will have to use a square to make the projection of these points, and drawing these lines coming down, lines from 2 3 5 and 6. The step number 4, it is to make what we call a sketch out line. Sketch out lines is this one, and this. Okay. After putting this sketch out, you need to make sure that the sketch out, the height of sketch out, it is equal to the height of the object. And then the length of this sketch out will need to be equal to the circumference of our cylinder. And then the last step here, you will take a divider, you will measure the segment, which is given by the space angle, this segment, which is equal to this, equal to this, equal to this. And then here we are having how many intervals? 1 2 3 4 5 6 intervals. So means here we will start by 1. This line, it is coinciding with this, so it is 1. And then we put by using a divider, we put the dimension here. It will be 2 3 4 5 6, means this distance is equal to here between 1 and 2. Okay. And then we reach to 7 it is here. And then by putting a second half, so that the circle will be like that, so we will come from 7 6 5 4 3 2 and 1. So from there we will be finishing our development, because if you take this one, you bend it to come here, so you will be having a cylinder, and then you can wear it, or you can put seaming. Thank you very much for watching this video. We can make you remember that this is sheet metal and fitting. We can make you remember that it is may be used in metal, and this metal may be ferrous or may be non-ferrous. You can make you remember about the seaming, that it is used to join or to ensure that there is no leakage. We can make you to remember that development, it is used as a plan, or yes, as a plan of what we need to do as a product. Thank you very much. See you again.